identifying holes, vertical asymptotes, and horizontal asymptotes. This is going to be very important like next week, really like Thursday when we start doing limits. All right, so this is stuff that you need to remember if you've forgotten. Holes, vertical asymptotes, horizontal asymptotes. Let's jump into number one. So as I look at number one, first thing I'm going to do are these two, holes and vertical asymptotes. Okay, it's a hole if you could plug in a number and get 0 on top and 0 on bottom. There is no number that you could plug on top and bottom to get 0. Remember also if it cancels on top and bottom, that would happen. So no holes on the first one. In fact, I don't know if there's a lot of holes on any of these. Vertical asymptote. I'm going to have a vertical asymptote at x is equal to what value? At x is equal to 4. There's going to be a vertical line at x equals 4. Because if you plugged in 4, you would get 0 in your denominator. If you get 0 in your denominator, then your function is undefined. Therefore, you have a vertical asymptote. Kind of remember doing that from Algebra 2, I hope, or pre-calc. We got that. The next thing we're going to do is find horizontal asymptotes. And again, this is an important concept. Okay, there's a couple different ways to look at it. Back in pre-calculus, when I taught my students, we had this cool little chart here, and we looked at the degree of the numerator and the denominator to try to figure out what was going on. Okay, and you can do that. The best way to decide where the horizontal asymptote is going to be is to plug in a really big number. Okay, like infinity. If you were to look at this graph as I looked on the edges, what would happen? If I plugged in infinity on bottom, I would get infinity minus 4, which is still a giant number. Everybody agree with me on that? A huge number on bottom. You have 2 over some giant number. Okay, if you have 2 over some giant number, what number is that really? If you had $2 and you divided by a bajillion people, how much money did everybody get? Nothing. You got nothing. There is a horizontal asymptote at 0. All right, because if I were to go towards the edges of my graph, if I were to look at the left and the right, it would get closer and closer to 0. Okay, the other way you could do that is on top, x is to the 0 power. On bottom, x is to the first power. If your numerator is less than your denominator, if your denominator is bigger, you have a horizontal asymptote at 0. Let's look at number 2. First thing we're going to do is find vertical asymptotes. To find vertical asymptotes, set the denominator equal to 0 and solve. Divide by -2, divide by -2. X is equal to 4. I'm sorry, x squared is equal to 4. So I'm going to have a vertical asymptote at x equals what? 2 and positive and -2. If I plugged in 2 on top, I wouldn't get 0. If I could plug in 2 on top and get 0, then it would be a hole. But since I just plugged in 2 on bottom and get 0, that's a vertical asymptote. The next thing I'm looking at is a horizontal asymptote. To look at horizontal asymptotes, again, you're thinking of the degree. What's the degree of the numerator? What's the degree of the denominator? On top, what's the biggest exponent on top? 2. What's the biggest exponent on bottom? 2. They're both 2. So if they're both the same, then we look at leading coefficients. Okay, leading coefficients. In front of that thing, there's a 1. In front of that x squared, it's a -2. So I'm going to have a horizontal asymptote at y equals -2. I'm sorry, not -2. I lied to you. What is it really? -1/2. Sorry. It's a 1 on top and a 2 on bottom. Again, if you go back to that thing I was saying with you plug in a really big number. If I plugged in a really big number on top, that would be a huge number. It's infinity squared. I would get that same big number on bottom. So really those two things are going to cancel, leaving you with just the -1/2 left over. Okay, if they're the same, they're going to cancel. You're looking at leading coefficients. Let's look at number 3. Set the bottom equal to 0. That's how I'm going to find vertical asymptotes. I need to factor here on bottom because it's an x squared. Okay, I can factor that. What do you notice about both things on bottom? They have an x. So if they have an x, take an x out. I took an x out of both things. They both had an x on bottom. I took an x out of both. Then I'm going to take each thing and set it equal to 0. So here's one, x equals 0. I'm good with that. The second one, I'm going to subtract 6 and then divide by -3. X is equal to 2. So 0 and 2. What happens if you plug in 0? What do you get on top when you plug in 0? 0. What happens on bottom when you get 0? You get 0. That's 0 over 0. That means there's a hole at 0. Okay, you could have looked at this problem initially and said, ooh, I could factor an x out on top, and I could factor an x out on bottom. And the idea that those two things are going to cancel, that is what's telling me there's a hole at 0. You could have done it that way. We did it the other way, where we found the vertical asymptotes and then plugged back in, and it works the same way. If I plug in 2 on top and bottom, would I get 0? No. So when I plug in 2 on top, I don't get 0. So that just means it's a vertical asymptote. So there's a hole at x equals 0. There's a vertical asymptote at x is equal to 2. Then I need to do horizontal asymptotes. Anybody starting to figure out horizontal asymptotes? Where would my horizontal asymptote be here? We don't have to mess with that. Here's the good news. You're right. There would be an oblique asymptote, but we don't care about that here because we're just asking horizontal or not. There's not a horizontal asymptote here. Okay, on top it's cubed. If you plugged in infinity, a giant number, and you cubed it, that's a really big number. On bottom, it'd be a big number too, but it'd only be squared. Okay, if you have a number on top that's really, really, really big, you got a bottom number on bottom that's big, but on top it's really big because you're cubing it. What number is that really? A really big number. It's never going to stop growing. It's going to keep growing forever and ever and ever. So there is no horizontal asymptote because that number is never going to stop growing. The more you go, the bigger you get, the more bigger and bigger it's going to grow. It's never going to stop growing. There is no horizontal asymptote there. We do not have to do oblique asymptotes. We couldn't care less about oblique asymptotes in calculus, so that's good. Backside. Number 4, first thing we're doing, set the bottom equal to 0. We're finding vertical asymptotes. All right, subtract 36. Divide by -4. Show me with your fingers. Where are you going to have horizontal or vertical asymptotes here? I should be using both hands, right? 3 and -3, both of them. Okay, 3 and -3 because we got to square root that 9. I'm going to have a vertical asymptote at x is equal to 3 and -3. Are either of those holes? If I plug a 3 on top, am I getting 0? -3 on top? No, I'm good. Okay, so they're not holes. Those are just straight vertical asymptotes. Then I'm looking at horizontal asymptotes. What is the biggest exponent on top? 2. What's the biggest exponent on bottom? 2. They're both 2. Cool, they match up. That means I'm going to look at leading coefficients to tell me the horizontal asymptote. On top, it's a 1. On bottom, it's a -4. So I have a horizontal asymptote at y, because it's a horizontal line, right? Look at my arm. This is a horizontal line. It's a line that goes like this. If it's a horizontal line, it's going to cross the y-axis. And if it crosses the y-axis, it's a y equals line. So there's a horizontal asymptote at y equals -1/4 because of my leading coefficients, -1 and a 4. You starting to remember some? And if not, are you just learning it for the first time? I'm cool with that too. I don't really care when you learn it. That's why we do this. Let's look at number 5. Okay, first thing we're doing, finding vertical asymptotes. Take the bottom, set it equal to 0. I need to solve that thing. What can I do on bottom? Okay. I can divide everything by 2. If they have something in common, take it out. Because you guys don't like factoring when there's a 2 in front. The good news for you is, hey, I can divide everything by 2. Well, if I divide everything by 2, now it's just this. Oh, okay, cool. I have to factor that. You got to remember how to factor. But you're better at factoring when there's not an x value in front like that. Or a number in front of the x squared. Cool? So now I'm factoring this. I need 2 things that multiply together to get me -2. And they have to add to get me -1. -2 and +1. Let's just double check. -2 times 1. Yep, that gets me -2. -2 plus 1. Yep, that gets me -1. I'm good to go. So I have a vertical asymptote at x is equal to 2 and -1. If you don't believe me, plug in 2, you get 0 on bottom. Plug in -1, you get 0 on bottom. And if you get 0 on the bottom of a fraction, and it's going to give you a vertical asymptote. Next thing we do is horizontal asymptote. What is the biggest exponent on top? 0. There's not one. It's 0. On bottom, it's squared. So it's bigger on bottom. If you have a bigger number on bottom, it's going to keep growing and growing and growing. On bottom, what number am I getting close to? 0. Horizontal asymptote at y equals 0. And hopefully at this point, number 6 shouldn't be too bad. X minus 4 over x plus 2. Take the bottom, set it equal to 0. Vertical asymptote at x is equal to -2. Got my vertical asymptote. Is it a hole? No, because if I plug in -2 on top, I wouldn't get 0. So we're good. Vertical asymptote at -2. Then we're going to do horizontal asymptote. Show me with your finger. I'm going to have a horizontal asymptote at y equals what here? Horizontal asymptote at y equals 1, because the exponents are both x to the first. So we're looking at leading coefficients. It's 1 over 1. My answer is 1. You have forgotten some of it? Cool. I'm reminding you now. Get back into the feeling.